I'm Nathaniel Taylor. I'm 20 years old. I major in Associates of Science at Durham Tech. The reason why this poster is behind me is because I participated in a summer research program this past summer at East Carolina University. And the way I started was back in September of 2020, I was working out, right? I started working out. And as I worked out, I loved the physical benefits, the mental health benefits, but also developed an interest in biomechanics because I was interested in how the body functions mechanically and stuff of that nature. So shortly after that, I contacted my advisor and I expressed my interest to transfer from engineering to science, and I told her I want to do biomechanics. And soon after that, she sent me some information about the summer research program at East Carolina University, and I immediately applied because I knew it was the correct program for me to be in because it was biomechanics. It was right up my alley. It matched my new interests. And so a typical day in the lab is I go to this lab, and it's actually a sports performance lab. So it's a lot of weights. There's a machine in there called a dynamometer. There's these, I can't remember the exact name of it, but it's these plates that you can stand on, these big wide plates that may be like 15, 20 yards long and like 10 yards wide that calculate different athletes' movement, stuff like that. It's a sports performance lab. And usually a typical day is I go in there, I go to a desktop computer, and I'm working with computer simulations all day, which is on my poster behind me, as you can probably see, is a musculoskeletal model. That's where I built that using this software called OpenSim. And basically every day, all 10 weeks throughout the summer, I spend 8 hours a day tinkering with it, trying to get different calculations on it, trying to get it to run and move and go through the process of it. But that's a typical day in the lab. And that's about half of the week where I'm just in the lab all day working on it. And maybe the other half of the week, all the participants in the program, we go to a different part of the campus and we go to a workshop or a luncheon to learn different stuff like how to apply to grad school, how to develop an elevator speech and things of that nature, how to write a good grant, stuff like that is all a part of the program and it lasts the duration of the program. My project was a muscle-actuated simulation of a single leg hop test. So some of you might know about ACL injuries. It's one of the most gruesome injuries that an athlete can suffer. And after they suffer that injury, these athletes have to go through what's called a single leg hop test. And a single leg hop test basically is a test that evaluates where that athlete is at in their return to play status, which is basically their overall health. And the problem with the test is that a lot of times while a participant or a subject, an athlete is doing the test, a lot of times because they're injured and because they tore their ACL, they have to compromise some of their muscles to perform the test. Like they'll recruit their hip extensors and their ankle flexors to be able to perform the test. And what that does is that it provides misleading information back to the person performing the test, like the doctor or whoever is performing the test on the athlete. And we need a way to get a better and more accurate reading of where the athlete is at in their recovery process because, like I stated, the athlete is providing misleading information by recruiting certain muscles. So the way that I go through the process of doing this, and again, this is a new concept that is kind of still in the process of being developed. This is something that hasn't really been done before. So what I'm trying to do is create a simulation of the single leg hop test and calculate the torque in the ankle extensors and the hip flexors, or the hip extensors and the ankle flexors, to get a better, more accurate reading of where the athlete is at in their recovery process. So I'll try to go as fast as I can and be as brief as possible. Where we start is with a musculoskeletal model in the software called Visual 3D. And first we have to scale it. There's also, if you could see, there's some lines coming out of the musculoskeletal model, and all of these lines represent the axes that have to be lined up correctly for the musculoskeletal model to then be transported into another software called OpenSim, which is where we're going to be doing most of the work. So after it's scaled, after we make sure that all the axes are straight, we can then transfer or export that model into OpenSim. Once we export into OpenSim, then we go through a 3-step process that involves inverse kinematics, the residual reduction algorithm, and computer muscle control. And it's a long, drawn-out process that hopefully will bring us the results that we need to get the torque in the hip extensors and the ankle flexors. And if we can get those two things right there, the torque and the hip extensors and the ankle flexors, then we can accurately evaluate and accurately assess where the athlete is in their return to play process. The program was 10 weeks long. I stayed at this place called Cotton Hall, in the dormitory called Cotton Hall. I worked about 40 hours a week, so that's about 8 hours a day during the 5-day week. I went to the lab for 8 hours, then I had the rest of the day to do whatever I want. This opportunity for Durham Tech students is very crucial and very imperative for a lot of students, in my opinion. For me, I wrote in my personal statement to get into the program that I thought that this program could bring my career journey and my academic journey to the next level. And it did just that. Probably one of the biggest draws that could probably influence a lot of people to want to go into this program is the fact that you have a lot of fun. Literally every single week, all 10 weeks, there's an activity that we're doing as a group, having fun. Greenville's a pretty nice town. It's got a lot of stuff to do. It's really fun. So it's a guarantee that you're going to have fun. If nothing else draws you, hopefully that can draw you. I guarantee you will have fun. I'll be graduated at the end of this spring semester of 2022. After that, I'll be transferring to Oakwood University in Huntsville, Alabama, majoring in communications and minoring in broadcast journalism. And like I said, the program, that summer research program that I was at ECU this past summer, it benefited me in a lot of ways. And one of those ways was my speaking and writing and things of that nature. When I made my decision to go into communications and broadcast journalism and become a newscaster, I could look back and pinpoint many different areas during the program and at the conference that kind of prepared me to go into the field that I'm going into now. So that's why I tell students the possibilities are endless. No matter what your interests are, the program can benefit you one way or another. I guarantee it.